right, there you go.
Bravo.
Here we go. Here we go. Thank you. All right. First of all, let's start with what Ryan said. I mean, basically, you could go cosine of 75, and you get an answer. Okay, 0.2588. Blah 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 blah. Okay. Now that really is only an approximate answer. It's a decimal answer. Okay. It's not incorrect, but if we want the exact answer, okay, the exact answer would be some square root answer. Okay. We're going to use the unit circle to help us find. Okay. So if we look at the unit circle, 75 is not on there, right? But 30 and 45 are. Are you guys paying attention? Okay. 30 and 45 are. So I do know this. If I were to look at this problem and rewrite as, okay, cosine of 75 is the same thing as cosine of 45 degrees plus 30 degrees, okay? I want to find values that are on the unit circle, because if I use the unit circle values, then I can get exact values. So what I have is really cosine of some angle plus another angle, right? Where 45 would be the theta and the 30 would be the phi. So it matches up to my formula. So if I go to my formulas, cosine of theta plus phi, I'm going to use this one right here. So I'm just going to go ahead and go cosine theta, cosine phi minus sine theta, sine phi, but instead of theta and phi, we're going to use the 45 and 30, because in this example, we're going to let theta be our 45 degrees. We'll let our phi be our 30 degrees. So we're just going to plug the numbers in where they go, and then we're just going to use the unit circle to get the exact values. So I'm going to go, all right, cosine then of 45 plus 30, which is a 75 degree angle, is going to equal, okay, to get the exact value, we're going to plug it in the formula. Okay, cosine of 45, because that's theta, cosine of phi would be 30, plus, minus, use the right formula, minus cosine, sine, use the right formula, sine, here it is, of theta, which is 45, and then sine of 30, which is phi. All right, so we just plugged it in. I'm using the formula cosine theta, cosine phi, minus sine theta, sine phi. The reason I use this formula is I'm really taking a cosine plus two angles. That's why I'm using this particular formula, okay? Now I'm just going to get the values from the unit circle. So my cosine of 75 degrees, I'll change it back to 75, which is my question, right? Cosine of 45 from the unit circle. Cosine is the x value, and at 45 it's the square root of 2 over 2. Cosine of 30, I go to the unit circle, 30 degrees for cosine is the x value, square root of 3 over 2. Minus sine of 45, again sine is on the unit circle, 45 degrees, it's the y value, which is square root of 2 over 2, times sine of 30, go to the unit circle, sine is the y value, which is a 1/2, right? Now we're going to simplify that. So I just took these values from the unit circle, all right? Cosine 45, cosine 30, sine 45, sine of 30. Now let's go ahead and simplify this. So I'll have the square root of 6 over 4 minus the square root of 2 over 4. I'm just going to multiply. I can combine them because I have a common denominator, which is 4. And so my answer finally is going to be the square root of 6 minus the square root of 2 over 4. That's the exact answer. It's decimal equivalent, sure, it's going to be about a 0.2588, blah, 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 blah. But the exact answer is the square root of 6 minus square root of 2 all over 4. Okay? All right, example 2. Cosine of pi 12ths. Now, pi 12ths is not on the unit circle, okay? But we've got to think fractions, all right? So, thinking fractions like 1/12th, okay? If I think about a 1/12th, oops, I'm giving myself away here, 1/12th. So, how can I make a 1/12th? So, I'm just thinking of the pi 12ths as a fraction, 1/12th. Well, I'm thinking if I go 4/12ths minus 3/12ths. Now, why would I want to go? So, I'm thinking this is the same thing as 4/12ths minus 3/12ths, right? Okay, now 4/12ths, 3/12ths, well, why would I want this? Because this would reduce to 1/3, right? The same thing as like a 1/3 minus a 1/4. But in terms of pi's, if I have a 1 pi 12ths That's the same thing as a, well, 4/3 minus 4/12 minus 3/12 is going to be 1/12. But that's, if I terms of pi, then I really have a pi third minus a pi fourth. Okay, let's use that information. So again, what I had to do is I had to think common denominators. I had a 1/12. Okay, so think of this as being a 1/12. How do I make a 1/12? If I go 4/12 minus 3/12. How does that help us? Well, this reduces to pi thirds, which is on the circle. This reduces to pi fourths, which is on the circle. So if we let our theta be our pi thirds and our phi be our pi fourths, then what I'm really looking for is cosine of, in a sense, I'm going to write it down, we're going to have a pi thirds minus a pi fourths, all right? That's what I'm really looking for, because that is a cosine of pi 12s, okay? That really is a cosine of pi 12s. This one's a little bit harder because you have to think fractions, and of course fractions are never easy. So how does this work? Well, let's go ahead and see if we can find that formula on our notes, okay? So if we take a look at our notes, look for cosine minus two angles, and I find it right there. I've got my cosine theta minus phi, which for me is cosine of pi thirds minus pi fourths, okay? So we're going to go cosine theta. Well, theta is my pi thirds. Cosine phi, which is my pi fourths, plus sine of theta, which is my pi thirds, sine theta, which is my pi fourths, right? So now, let's see what we can do with this. Unit circle. I go to the unit circle. Cosine is the x value. If I go to pi thirds, I get an x value of 1/2. Cosine of pi fourths, cosine is the x value in the unit circle, and that's going to be a square root of 2 over 2. Plus, how's that? Is that better? You guys see that better? Sine of pi thirds, again on the unit circle, sine is the y value, square root of 3 over 2, times sine of pi fourths, from the unit circle, y value, square root of 2 over 2, okay? Now, I just need to simplify this. So I get a square root of 2 over 4 plus a square root of 6 over 4. And then what I can do is combine them to make the square root of 2 plus a square root of 6 all over 4, because that's my common denominator. Okay, that's the exact value. So all you're doing is first just trying to find two numbers, two angles that add up or subtract to make that, and then just use the correct formula. Okay, so example 3. All right, if I take a look at it, and if I let theta be 20 and cosine be phi, theta is 20 and 40 is my phi. It looks like I've got sine, cosine, plus cosine, sine. So I'm looking for that one. Sine, cosine. So if I look through my notes, seems like it's my very first one. Seems like it matches up pretty well to this particular formula. Yeah.
Would on the second part, wouldn't the cosine be phi rather than theta?
Oh, yeah.
20 degrees?
Oh, I know.
2040, 2040. So it's got to be theta phi. But good question, Colby. Do you see how that's my 2040? So it's got to be my 2040, right? Okay, so I think it matches up to this one, doesn't it? Sine theta, cosine theta, plus my cosine theta, sine. So what we're going to have to do is call this sine of 20 plus 40, right? Which would be sine of 60. All right? And sine of 60, that's on the unit circle, isn't it? This one was pretty easy. Sine of 60, it's on the unit circle, turns out to be exactly the square root of 3 over 2. That was a lot less work. We just had to take it. That's it. So let's see what I did. One more time. I used sine of 20, 40. Got sine 20, cosine 40. So I recognized it as this. So I rewrote as sine of 20 plus 40, which is really sine of 60, and that's on the unit circle, isn't it? Which goes straight to sine value, which is square root of 3 over 2. Okay, that's pretty easy.
Wait, what about the cosine part of this?
Okay, let's see if I can explain this better. Okay, one more time. So let's just look at this. Okay, 20, 40, right? So sine, cosine. So this, it matches up to this perfectly. Okay, so let's write it backwards. So all of this would have to equal sine of theta plus phi, right? So I'm going backwards with it. So let's rewrite it. Sine of theta plus 40, right? So this had to have come from sine of 20 plus 40. Well, I can add 20 plus 40. That's 60, right? Well, shoot, sine of 60, that's on the unit circle, isn't it? So I go straight to the unit circle. What is sine of 60? Square root of 3 over 2.
Okay.
So I worked the formula backwards. I recognize that in its expanded form, it came originally from sine of theta plus phi. 20 plus 40 is 60. I can do that on the unit circle, can't I? All right, turn the page. All right, so now we want to prove that cosine of pi halves minus x is equal to sine of x, okay? That's one of our identities. And the way we're going to prove it is using this formula right here. I'm going to prove it using this one right here, because I'm going to have, instead of theta plus phi, I'm going to have pi halves minus x, but I have an angle minus an angle, okay? So I'm going to use this one right here. All right, go ahead and get that so you can see it. So in this case, let's let theta be pi halves and phi be x. So theta will equal my pi halves. You guys can see that. There you go, perfect. And we're going to let phi be x. So let's set up the formula. So we're going to rewrite this as cosine pi halves minus x is equal to cosine theta, which is pi halves, times cosine phi, which is x, plus sine of theta, which is pi halves, times sine of phi, which is x. Okay, so I just set it up. My two angles, theta, phi. I've got cosine minus an angle. I've got an angle minus an angle, so it has to be this one. Cosine of an angle minus an angle, so I just set up cosine of theta, cosine of phi. Which would be cosine of pi halves, cosine of x, plus sine of theta, sine of phi, sine of my pi halves, sine of my x, okay? Just plugging them in, okay? Now, from the unit circle, somehow this is going to all simplify all the way down just to sine of x. So let's see if that happens. So, cosine of pi halves. So go to pi halves, cosine's the x value, which is 0. Ooh, I like that. It's getting simpler, isn't it? So I get 0 cosine of x, right? Now, I don't know what cosine of x is, but it doesn't matter, because we're going to multiply it times 0, and it's just going to disappear, right? Plus sine of pi halves. Sine of pi halves is, on the y value, it's 1. I don't know what sine of x is, but it doesn't really matter because I'm going to multiply it by 1. Well, this gets pretty easy. This becomes 0. That's gone. And then this is just 1 times sine of x, which is just sine of x. So let's see what I've proven. I have proven that cosine of pi halves minus x, sure enough, is equal to sine, just by using my formula. Okay, last one. One more proof, okay? So tangent. Let's see what we've got. We've got tangent of 1 plus x, 1 minus tangent of x. So I'm going to use that one. Matches up perfectly, okay? So let's go ahead and write this. We're going to actually kind of work this one backwards. Let's go ahead and let phi be pi force. And let's let theta be pi force and phi be x, okay? Theta is pi force and phi is going to be x. So I'm going to rewrite it. I'm going to go ahead and put it as the tangent of pi force plus x has to equal. Let's check out the formula, okay? So I'm going to use this formula right here. So I'm going to go equals tangent of phi, or tangent of pi force, because that's my first angle, okay, plus tangent of phi, which is x, because that's my second angle, okay, divided by 1 minus tangent of theta, which is my first angle, so I'm going to go tangent pi force, tangent of phi, which is my second angle, which is x, okay? So I just plug them in. I'm going to let this be my first angle. That's my theta, and that's my phi. I plug them into theta and phi, pi force x, pi force x. All right. So let's go to the unit circle and see what we get. Okay. So tangent of pi force, well, it's the x. It's on the outside of the circle. It's just 1, right? So I get 1 plus tangent of x. I don't know what x is, so I have to leave it as tangent of x. I have no idea what x is. But that's okay because it's kind of looking like it should anyway, right? Over. Well, 1 tangent pi force, what do you know, is 1 times tangent of x, which I don't know. I'll just call it tangent of x. I don't need the 1. I don't need the 1. So let me just rewrite it finally as, so I can prove that tangent of pi force plus x is equal to 1 plus tangent of x over, oop, there's a minus there. There's a minus there. There's a minus there, darn it. It's Monday. 1 minus tangent of x. There it is. We have proven, okay? All right.